Okay, to solve these problems, we need to draw the networks on a map, or what we call utility drawings. To do this, we need to do survey. But how can we do the survey when these networks cannot be seen? A good start is to visit the chapters of electromagnetics in your high school's physics, which you may have already forgotten, of course, but the great scientists like Michael Faraday and James Clerk Maxwell told us an important fact is that the alternating electrical field and magnetic field are coupled to each other. And they propagate in vacuum, in free space, in air, and in materials. Existence of one of them generates the others in the perpendicular directions. So how is it related to our UU survey? Then coming back to this survey, what if we inject an alternating current in the mysterious valves behind the black covers, and then detecting its magnetic field on the road surface? Does it work? Or perhaps the power cable itself can generate certain signals detectable by a certain device. Yes, there is such device called coil, or in a modern terms, an instrument called electromagnetic pipe cable locators, PCL, or what the geophysicists call magnetometer to detect these signals. It works based on the early discovery by Michael Faraday in the 18th century, and we now apply it to locate and position our complex undergrounds by the web. The principle is that on a site, and after reading the not-so-accurate record drawings of the UU, we can open a valve chamber which connects the pipes. Then on one end, we inject an alternating current into the pipe, and on the other end, ground the circuit somewhere away from the chamber. Now a circuit is made, and the alternating current flows through the pipe. Magnetic field is then generated radially and in all directions centered to the alternating current where the pipe is. And what you can do is to carry your PCL or magnetometer, sweep the PCL radially about the connection point, and observe the strong and weak signals and identify what we call the low-high-low signal pattern. This signal strength is the magnetic field strength, and the stronger signals you receive, the closer you are with the pipe. The positions where you observe the highest signal strength is where the pipe lies directly underneath. Then do another step to confirm the alignment, turn 90 degrees and observe the die down of the signals, because magnetic field does not travel along the pipe, but perpendicular to the pipe. And turn the PCL back to the alignment and just touch the ground. Simply press the depth buttons, which measures the magnetic strength, and record the depth values. So up to this point, you have got two pieces of information. First, you have the locations or X and Y from a reference point, where the highest signal strength is found. Second, you have the depth confirming the X and Y. When we do measurements, we always say one data is no data. Now you only have information at one point in the PCL survey. So now make a few steps forward and repeat what you have done. Then you will have 3 confirmed points. That is the connections at the valve, the first measurement point, and the second measurement point. With 3 points, you can draw a line, and now this line becomes the alignment of the underground utilities that you're interested in. It is also important to record the information in a log sheet, spray paint or mark the information on the ground, and later on survey the exact positions with total stations or GPS. Tools that give you true coordinate in a map. Then with all these informations, you can draw the alignment and produce underground maps of all UUs in the site you're interested. And now based on these survey results, we can produce maps in CAD, GIS, and BIM. In fact, there are many methods to do such survey for different types of pipes, especially non-metallic pipes, like inserting a transmitting sonde or making use of a tracer wire attached to the pipe. In some cases, we do passive detections by making use of RFID installed in the pipe or power cable. For these methods, the principle of detections is more or less the same.